So you might remember from the introductory case that Hayden Seller, the bank manager of Sunnyvale Bank, wants to use historical data from 500 bank customers to develop a classification model for determining whether or not new bank customers will respond to a HELOC offer. He also thinks that Sunnyvale Bank is not targeting the right customers when marketing its HELOC products, and hopes that the classification model will offer actionable insights for his company. Hayden plans to assess the performance of the model and classify 20 new bank customers as likely or unlikely to respond to a HELOC offer. And we're going to use R to build the preferred classification tree, and then use this tree to score the new cases. So using R, the most popular algorithms for building decision trees in R can be found in the RPart package. As in the case of some other methods for building decision trees, R implements a k-fold cross-validation process for pruning decision trees using two-way partitioning. For example, only train and validation data. So the first step of the process I've already done on my screen, and that is to import data from the HELOC data file into a data frame, and then label it my data. The following instructions and results are based on R version 3.53. To replicate the results with newer versions, we can use a code, and most of you will be running a newer version of R, so this is probably going to be a pretty helpful tool, and that is suppress, warnings, and then a bracket, and in this case we want RNG version 3.53, and we'll run that. And now we won't run into any issues due to versioning of R. As it often happens, once you have R, you may not update it the most frequently, and that's totally fine. And then everybody's version of R may have different packages installed, and it really doesn't matter if you install a package, even if you've already installed it. It takes up time and it takes up space, but if you want to be absolutely certain, it doesn't hurt to go ahead and do it. So first I'm going to install the carrot package. And in this case, there are some dependencies or conditions we want to place on this variable. So we type dependencies. And in this case, there's a set of things, depends, and suggests. That's installed. Some things are very straightforward, simple, and quick to install, and other things take a little bit longer. By now, many of you have probably learned that a lot of data analytics is sitting at the screen and just watching it work, and that's okay. This is why it's so important to have a cup of coffee or something else, depending on the time of day, to sip on your desk, because there are moments of downtime. I know my favorite right now is green jasmine tea. It's fantastic. The good news is that when we use prediction trees, we'll be using a lot of the same packages and we won't have to install them. If you already have a package loaded, you can use the library function just to pull those functions into your working space. And it's still going. Some packages are just larger than others. And because of the open source nature of the development of R applications, they may not be the most linear and compact in terms of their code. Many of them have been modified and adjusted over time, and the code is often very messy. It's functional, but it's not what you would call tidy. And that can slow things down a bit, and that is one drawback to using R. But it's also kind of cool that if there's something that you can imagine or dream of that you want to accomplish, you can do just about anything in R because of that open source nature of the programming language. And my cat Sylvester just came in to supervise. For those of you who don't know, I have 4 cats. Sylvester's my favorite, and he's in here to help me work. Fact is, he'll actually probably start eating some homework, so it's good that we submit our homework on eCampus. So I don't have to apologize to any of you that my cat ate your homework. My goodness, we have to be getting near the end now. The R part package does a lot of different things, so it is a larger package. And here we can see a number of different packages were also brought in with it to help support its operations. So here we're going through the different packages and components that support our part and making sure they're unpacked and their sums are checked so they're capable of functioning properly. And well, frankly, that's what we all want. We always want it to function properly. And basically, for every single one of those chunks of purple code, we were looking at packages that work well with my data and can help support use of that package. So it's going to take a little while to get all the packages through as well. And some of the packages and components are larger than others. So there may be pauses between some of the package extractions. But we're getting through them. And the best part is we have 4 more packages to install. I'm sure everybody is super pumped about that. And this is the same example as in the text. So you're also welcome to follow along with the textbook so you can see what all the code looks like, and maybe skip part of the video if you realize that you may have some of these packages installed already. Every time it pauses, I feel like a brief excitement that it may be over, and every time I'm disappointed. But data analytics is kind of a cool field because on one hand, we're kind of merging liberal arts and computer science and statistics and math together, but we also have the luxury of time. It's important to take your time and think about things and let programs run. And that's kind of nice compared to a lot of other fields. We can take our time and think about things and talk about everything from cats to T to the field itself while R does its thing. And here we go. Sometimes when you modify versions sometimes you may run into issues installing packages because you may be running an out-of-date version of R. My first suggestion is that if you do run into a failure, to check your R version and update it if it is out of date. For a moment there, I was excited and I thought we were getting close to the end. Well, we made it. Now we install packages, games. Perfect. That one was a lot faster. Then we can install packages. Whoops, gotta put a period there, not a slash. Install packages. R part. First one we installed was Caret, then Gains, and now R part. Next, we're on to R part dot plot. When you're installing a package, you need to put the name of the package in quotation marks. Whoops, that was supposed to be install dot packages are part dot plot. That'll run much better. Like I said, even the most familiar users of R will run into issues like that. And then we have one last package to install. And it's PROC. Now, the trouble is I've installed these packages, but because there can be so many packages in R, we want to focus in our working directory only on those that we're actively going to use. So to specify, to tell the working directory which ones we want to use, we use the library function. So for all of the options, for all of the packages we just loaded, we're going to use the library function to make sure we can use them. First up is going to be caret. And what you see, it actually loaded two required packages that are required to make caret work, lattice and ggplot2. Next, we are going to add games to our working library. And next it'll be R part. And next it will be R part plot. And finally, it's going to be PROC. No quotation marks required with adding things to the library. So when we're constructing a classification or decision tree model, R requires that the target variable, in this case HELOC, be a factor variable, so a categorical data type. We can use the as factor command to convert the HELOC variable into a categorical type. So for example, we're going to modify a variable in my data, and it's going to be the HELOC variable. So here we're going to do as factor. So this is going to convert the HELOC variable into factors. And then I'll add my data. HELOC. And now that's been done. We can't see it, but it's there. And there are 4 different types. Then we can use the set seed command to set the random seed to 1. This generates the same partitions as in this example. We use the create data partition function to partition the data into training and validation data sets. Normally with training data sets, we use about 70% of the data, and in validation sets, we use about 30%. So first, we're going to set seed at 1. Then we're going to create a new object called myIndex. We're going to create data partition. Using the my data key lock, comma, P is equal to 0.7. So this is where we're determining how much is our training set. And then our list is false. Oh, typo in that line of code. The assignment error requires a dash. So now we've created the my index object. So now with our train set, we can look at my data and then my index to indicate we're only looking at our rows. We're not interested in columns at this point. Oh, when partitioning, you want to use square brackets, not round brackets. There we go. Oh, an unexpected symbol. What could that be? Oh, that's right. We are not looking at anything beyond my index. Some versions of R don't like that specification of the train set. So an alternative approach is to use C and then put my index in round brackets. There, that worked better for my version of R. So if the first attempt doesn't work, try that second attempt. And then the validation set, if I can type, the validation set uses my data, box brackets, negative sign for my index because we're using the inverse of the training data set in our validation set. Don't forget your commas, ladies and gentlemen. So we can use the rpart function to generate the default classification tree default tree. And within the rpart function, we specify the model, structure, data source, and method. The method option is set to class for developing a classification tree. To view the details about the default tree, you can use the summary function. Because R uses the cross-validation method for pruning the tree, to ensure consistency of the cross-validation results, we can use the set seed function to set a random seed of 1. So let's give that a shot. So we will set seed to 1, and then we'll create the default tree. We'll use the rpart function, and then heloc. And this may feel a little bit familiar from when you worked on regression working in R. The data is going to be the train set. And the method will be class. So we have set the seed to 1, and we've created our default tree using the rpart function with the training data set. Let's just see a summary of what this looks like. So we can see where the different splits are. And some of the key characteristics of all of them. We have our variable importance. Node number 1, we have information about the class counts, the probability, and primary splits that would appear in the table. So textually, it gives us just an overwhelming amount of data. To view the classification tree visually, which I recommend, we can use the PRP function. The type option is set equal to 1 so that all nodes except the leaf nodes are labeled in the tree diagram. This is very helpful. The extra option is set to 1 so that the number of observations that fall into each node are displayed. The under option is set to equal true to put the number of cases under each decision node in the diagram. So let's take a look at this. We're going to work with PRP, default tree, type 1, extra 1, and under true. And over here in our plots window, trying to pull it over to make it a little more visible. Make this as big as I can to make it as easy to see. But what we find is that we have 2 splits in the beginning, and then basically each node has nodes that come off of it. Some nodes will have a branch like from age to income, and then income again based on another range of the different amounts of income. Take a look in the text and and it will have a much clearer picture. And it's cool stuff. It's really cool to be able to see the results of these decision trees. And they're great for a lot of work presentations because we are often asked about the results and not as often asked about how the sausage is made. And this kind of pairs both. You can present the code that indicates how exactly you got this beautiful visualization, and it's a good matchup. So the number of splits determined in the default classification tree are determined by the complexity parameter in the rpart function, and it decides when to stop growing the tree. If the cost of adding another split to the tree exceeds the value of CP, then the tree growth will not continue. But in most cases, it's very difficult to know what CP value will produce the best performing tree beforehand. Therefore, a common practice is to grow the full tree and then prune it to a less complex tree based on the classification errors produced by a built-in cross-validation process of the rpart function. So if you want to go through the process of pruning the tree and checking out the full tree, I strongly recommend that you finish example 10.5 and take it from here. You have all the information you need to finish out the exercise, and you're going to do a wonderful job. Catch you next time, guys.